Hi, this is Robert Seigan for ISA 4220 for Professor Green. Today we're going to be talking about IMAP and DNS. Alright, what is IMAP? IMAP is an Internet Messaging Access Protocol. It is the go choice for most people these days for mail protocol. IMAP was created in 1986, but seems to suit the modern day world of omnipresence, always on the internet connectivity quite as well. The idea was to keep users from having to be tied to a single email client, giving them the ability to read their emails if they were in the cloud. Some basics for IMAP. IMAP allows you to access the emails wherever you are. Basically, email messages are stored on a server. When you check your inbox, your email clients, contacts, and the server to connect you to your messages. When you read an email message using IMAP, you aren't actually downloading or storing it on your computer. Instead, you are just reading it off the server. As a result of this, it's possible to check your email from several different locations, and the good thing is that you don't use any space on your hard drive. So if for some reason something happened to your computer, all your emails are still saved on the server, not like POP3. You can think of IMAP works like an intermediary between your email client and your email server. Email servers usually used when sending and receiving email messages. With IMAP, though, they remain on the server unless you explicitly delete them from the server itself. Also, unlike POP, IMAP also allows you to access, organize, and read and sort your email messages without having to download them. As a result, IMAP is very fast and efficient. The server also keeps record of all messages that you send, allowing you to access the sent messages from anywhere as well. IMAP doesn't move messages from the server to your computer. Instead, it synchronizes the email that's on your computer with the emails that are on your server. Now we're going to go through a few advantages of IMAP. There are several advantages. Like I said, first, it allows you to access your emails from anywhere. Second, it only downloads a message when you click on it. As a result, you do not have to wait for all the messages to download from the server before you can read them. Third, attachments. They're not automatically downloaded with IMAP. You're able to check your messages a lot more quickly and have greater control over which attachments are opened. And also, IMAP can be used offline just like POP, and basically enjoy the benefits of both protocols in one. IMAP most likely is sure to remain the protocol of choice of most of today's businesses. Like I said before, you can have multiple logins with IMAP. Most implemented on IMAP support multiple logins. This allows the end user to simultaneously connect to the email servers with different devices. Details on how to handle multiple connections are usually specified by the protocol, but instead left up to the developer of the email client. IMAP runs on port 143, which on 143, this is the default IMAP non-encryption port, and port 993, of course, is the encrypted IMAP mail port. Security protocols come out with SSL as well as TSL. Both provide ways to encrypt communication channels between two computers. TSL is the successor to SSL in terms of SSL and TLS are used interchangeably unless you're referring to a specific version of the protocol. Best practices for IMAP using SSL/TLS. Nowadays, start TLS command is is the preferred way to start TLS encryption for the connection. Unfortunately, a lot of servers block port 143 and only allow port 993 IMAP because it's easier to implement in firewalls, and it avoids problems with bad clients sending passwords in plain text. Some other best practices is to use very unique usernames. When using unique usernames, it makes it more difficult for someone to target your work account to also target you via your personal account. You definitely want to configure your authentication. Even though IMAP has an authentication mechanism, the authentication process can easily be circumvented by anyone who knows how to steal a password by using a protocol analyzer, because the client's username and password transmitted in clear text. In an Exchange server environment, administrators can work around this security flaw by using SSL encryption for IMAP. You always do want to keep your system up to date, of course, and you definitely want to be able to configure your mailboxes. DNS. What does DNS stand for? DNS stands for Domain Name System. DNS was created by Paul McTriss. Expanded the internet beyond its capability origins by inventing the domain name system. It was created in 1983. Most people call DNS the phone book of the internet. Basics about DNS. DNS is a client/server network communication system. DNS clients send requests to receive a response from the DNS server. Requests containing a name that result in an IP address being returned from the server are called forward DNS lookups. Requests containing an IP address and resulting in a name are called reverse DNS lookups. DNS implements a distribution database to store the names of the last known addresses and information from all public hosts on the internet. The DNS database resides on a hierarchy of special database servers. When clients like web browsers issue requests involving internet host names, a piece of the software called the DNS resolver first contacts the DNS server to determine the server's IP address. If the DNS server does not contain the needed mapping, it will forward the request to a different DNS server at the next higher level in the hierarchy. A client computer will always send a DNS query using UDP protocol over port 53. If a client computer does not get a response from a DNS server, it must retransmit the DNS query using TCP after 3 to 5 seconds of intervals. I just wanted to go back real quick. DNS organizations, servers, when we were talking about the hierarchy, for the internet, it's so-called root names servers reside at the top of the DNS hierarchy. The internet root names server, DNS server information from the web top-level domains like .com, .org, .net. So that's part of the hierarchy, is the .coms. That's the top level, and then the next level would be the name itself. So it'd be like Yahoo, Google. So just wanted to let you know about that. Another thing you can do with your DNS is set up a DNS cache. To better process high volumes of requests, the DNS utilizes caching. DNS caching stores local copies of recently accessed DNS records, while the originals continue to be maintained on their designed servers. So this way, they don't have to go back to the server every single time. If you're looking for that, if you're looking for Google or something like that, it's stored locally, so you can go right to that IP address instead of having to contact the DNS servers all the time. ICANN stands for Internet Corporation for Assigned Names and Numbers. This is a nonprofit governing body that controls basically the website's names and allocations. When it was first implemented in 1980, however, DNS defined only 6 TLDs, which is .com, .edu, .gov, .mil, .net, and .org. By now, it's expanded to a lot more than just that. Also, when talking about DNS, there are some terminologies out there, like resolver, which is a DNS client that sends the DNS message to obtain information about the requested domain namespace. You get recursion. Recursion is the action taken when a DNS server is asked to query on behalf of a DNS resolver. You have authoritative server. It's a DNS server that responds to a query message with information stored in R&Rs for a domain namespace stored on the server. Recursive resolver, a DNS server that queries for the information asked in the DNS query. So these are just some basic terminologies used when talking about DNS. Best practices for DNS servers: manually configuring the ACL or access control list. By manually configuring it, you can provide a static anti-spoofing protection against attacks in utilizing unused or untrusted address space. Next, you have IPS and Cisco iOS net flows. Cisco IPS or intrusion prevention system, and the NetFlow feature provides compatibilities to aid in identification and mitigation for DNS-related attacks. Next, you have Domain Name System Security Extension, or DNSSEC. DNS security extensions add security functions to the DNS protocol that can be used to prevent some of the attacks, like DNS cache poisoning. DNSSEC adds data origin authentication and data integrity to the DNS protocol. Next, you have unicast reverse path forwarding. Unicast reverse path forwarding is a feature that can reduce the effectiveness of packets with spoofing source addresses. A network using unicast RPF evaluates the source of each IP packet against its local routing table in order to determine source address validity. While it can detect and filter some spoof traffic, the unicast does not provide complete protection against spoofing, because spoofed invalid packets with the same source address may arrive on the same interface. So it helps a little bit. Next, you have use Active Directory integrated DNS zones. This improves security and simplifies DNS replication. AD integrated zones allows the user to secure dynamic updates. This prevents updates to DNS records from machines which are unable to authenticate with the domain. If you really wanted to, you can always disable the dynamic updates. But by doing this, on the other hand, it does secure the DNS records, but makes management of the domain more difficult. Another thing you probably want to do is put in a DNS best practice analyzer. The DNS best practice analyzer checks for more items than are documented here, and provide guidelines for resolving any issues it may find. So it's probably a good idea to put in an analyzer. It'll tell you what you can do to fix the system and secure it even more. And of course, you probably always want to have antivirus on your server as well, and run through every now and then. malware can attack your computer in a way and change the DNS server settings, which can definitely cause you some chaos. So you probably want to make sure antivirus is up to date and on your server, and I would run it every now and then.